Okay, so hi everyone. So today in this video we are going to solve this problem from Leetcode that goes by the name numbers at most and given digit set. And this is going to be the fifth video in this digit DP playlist, right? So before starting this video, if you're new to this channel, so what you can do is you can just subscribe the channel and support me because there's already a lot of amazing content uploaded here as you can see. And if you want me to make more videos like this, then please like this video and share it with your friends who need to watch this series. So as you can see that I have created the dedicated playlists for every topic that I have uploaded till now. So this is a digit DP playlist, and as of now there are a total of 4 videos present, and this is going to be the 5th video, and there will be at least a total of 10 to 12 videos in this playlist, right? So if you want me to make these videos regularly, please support me and consider subscribing the channel. So let us get back to the problem. So the problem reads like this, that you will be given an array of digits which is sorted in non-decreasing order, and you can write numbers using each digits of I as many times as we want. For example, if digits array is given something like 1, 3 and 5, then what we can do is we may write numbers such as 13 or 551 or like this. That is, whatever the integers will be present in this digit array, we can only use those integers in order to construct our number, right? So we have to return the number of positive integers, that is the count of positive integers that can be generated using this digits array, which will be less than or equal to the given integer n. So this is the question, and here we are given with 3 different examples, and this is the constraint. So one important thing to notice is that whatever integers will be present in the digits array, it will only comprise from 1 to 9. That is, only positive digits can be used. That is, you will never have to use the digit 0, right? So this is the question. I hope you understood this. So let us now try to first think, why is it a digit DP question? So as we know that for a digit DP question there are 3 requirements generally. First, the constraint will be little high. So here if you see, then the value of n can go up till 10 to the power 9, which is pretty high, right? So this is one indicator. Second thing is that you will be given a range, but if you look here in the problem, then by looking it directly you will not see a range, right? But if you see it closely, then you will realize that you are given an integer n, and since it is written that we have to generate the count of integers which will be less than or equal to this n, right? So it means that this n is our rightmost limit, and since we only have to return the count of positive integers, so it means that our leftmost value will be nothing but this 0. The range is indirectly given here from 0 to n. And the third indicator is that since in the output we just have to print one integer which will represent the count of only specific integers in that range, so the same thing is expected here too. So that's why this is a digit DP question. Got it? If you have not yet studied digit DP before and you are directly watching this video, then I will highly recommend you to watch these first 4 videos, or at least this first video, in order to understand the concept behind this video in a better way, right? But if you already know the basics, like how we define states and use it, then you're good to go with this problem. So let us now get to the blackboard and see what concept we will apply in this problem in order to solve it efficiently. So let us go to the blackboard now. So let us start now. So we know that the range that we have to deal with now is nothing but from 0 till n, right? So if this is the given range, then we know that what we have to do. So first we will solve it for the rightmost part, that is this solve of n, and then we will solve it for the leftmost part, 1 less than the given. So since 0 is written, so 0 minus 1. So this will be the thing here, and we know that this will be equal to nothing but this solve of minus 1. That is, we have to check out for each and every possibility starting from 0 and going till minus 1 in this direction. And in this range, there is actually no integer, so that's why this will yield nothing but 0. So that's why the value of this part will be 0, so we can simply erase it. So that's why our whole focus will be on this part, that is solve of n. So this solve of n represents nothing but each and every integer present in this range, that is from 0 to n. So by solving, so that's why by calling this function, we will be actually exploring each and every integer present in this range, that is from 0 till n. And this is the same thing that we are given in this question as well, right? So that's why we are only concerned with the rightmost. And let me tell you one more thing. So since in this range 0 is also coming, but this 0 is actually not present in the digits array in any example. So since in this range 0 will also be one of the integer or the first integer, but since in the constraints it was written that the digits array can only comprise of digits from 1 to 9, that is whatever integer will form, it has to be positive, it can never be 0, right? So that's why what we can do now here is I will simply subtract 1, because we know that this 0 will never be a valid answer. So by calling and returning this, that is solve of n minus 1, what I will do now is I am simply checking out each and every possible integer in this range, that is from 1 to n, right? And why I am subtracting this explicitly here, you will realize when I will write the code at the end. So this. So I hope you got this point. So let us move forward now. So let's say that I'm considering an example here. Let's say the value of n that I have considered here is something like, let's say 74162, like this, right? So if I write the indexes here, then 0, 1, 2, 3, 4. And let's also suppose that the digits array that we are given here will comprise of some digit, and these digits will be like, so these digits will be like 3, 2, 8 and 9, right? So this is the value of n, these are the indexes, and here we are given with the digits, right? So now we know what we have to do. We have to construct an integer which will comprise of a total of 5 blocks, right? So if I draw those 5 blocks here, so this will be our first block, second block, third, fourth and fifth. So this is the first block, or the 0th index rather, first, second, third, fourth. So a total of 5 blocks are present, and we know that we have to start building an integer from this side, that is starting from MSB and going all the way till this LSB. So now we know that what we used to do in these types of problems. So what we do is, whatever value of n will be given, we will first convert it to a string. Why? Because we want to access these specific digits using their indexes, right? So in order to access the digits using their indexes, first we have to convert the given n into a string. And once this is done, let us start building our integer starting from this side and going all the way till this side. And we also know that whenever we will cross this boundary, then the value of index that we will get is 5, and this 5 is nothing but the length of this integer, that is a total of 5 different blocks, right? So let us start with the first block. So initially we'll be standing on this 0th index and we want to fill it, but with what values can we fill it actually? So since in the original string here for the 0th index the value written is 7, so it means that if I write here a value greater than 7, let's say 8 or 9, then what will happen is entire integer will become greater than this. But since in the question it was written that we always have to form an integer less than or equal to n, so it means that we can never fill 8 or 9 here. We can only fill starting from 0 till 7. So this is the only valid range that we can select. I hope you got this, right? So if I write here the possibilities of choosing the integers, so we can select 0, 1, 2, 3, 4, 5, 6 or 7, right? And we know very well that we can divide this case into 2 different cases. That is, what we can do is I can just say that this will be my first case and this will be our second case. Why? Because this second case represents nothing but the actual digit present in this string, that is at the 0th index, which is 7 here. So this is nothing but the upper bound. But we know that if you select any of the digits in the first case, that is from the first case, then if you select any digit from the first case, then from the next block onwards till the last block, the condition of type will turn to be false, right? Because if you select any integer from this range, that is from the first case, then no matter what digits you fill it here from 0 to 9, it will always be less than this n, which is a valid integer. So let's say I pick here this 7, that is the upper bound value only. So if I pick this 7 here, then what will happen? So let's say I have picked here 7 now, and by picking 7 I will move to the next block. And since I have picked 7 here, which is actually present in this string, then when I have moved to this first index, that is the next, then I want to fill this block. And if you look in this string for the first index, which is written 4 here, so it means that I can only fill with this block from integers 0 to 4. And if I try to fill it with any integer greater than or equal to 5, then again the whole integer will become greater than this, which is wrong, right? So that's why again if I write here, then what I can fill it with? I can fill it with either 0, 1, 2, 3 or 4. So these are the only possibilities now. And this will be our first case and this will be our second case. But we have already done a very big mistake, and intentionally I have not told to you by now. So see, what we have done is, since you remember in the question that it was told clearly that whatever integer you will be forming, you will only be forming using the digits given in this digits array. But here what I did was, when I picked the digit for the 0th index here, then I picked here 7. But clearly in the digits array for this example, 7 is not present, and if 7 is not present, then whatever integer it will form at the end, in that integer 7 will definitely be present. And if 7 will be present, that is a digit is present which is actually not present in this digits array. It means that the formed integer will be an invalid one, and it will not contribute +1 to our answer. It will not contribute, right? So that's why, let me erase these things. So that's why whenever we are filling it, we have to decide whether it is a valid digit or not. That is, whether that particular digit is actually present in this digits array or not, right? So if you look here, then starting from 0, we will see if this is actually present in the digits array or not. So as you can see here, that this 0 is not present, and if this 0 is not present here, it means that we can simply not use this 0. Similarly for this one, because this one is also not present, so we cannot use this one. But since this 2 is present here, then it means that we can use this 2. Similarly, since this 3 is also present here, so it means that we can use this 3, right? So if I mark here that what digits we can use actually, so it will be something like, we can use this 2, we can use this 3, and since we can only go till 7, and out of the remaining 4, 5, 6, 7, nothing is present here. It means that out of all the possibilities that we had initially, now we are only left with 2 possibilities. That is, either we can select 2 or 3 for this first block. Why? I just explained you, because these 2 and 3 are the only digits that are present in this digits array, and no other digit is present. And if you select any other digit apart from these 2, then the whole integer will comprise of at least one digit which is not present in this digits array, and that formed integer will be considered as invalid, and it will not contribute +1 to our answer. So that's why by selecting any other digit and moving forward is not feasible, because it will simply waste our time, because the formed integer will be already wrong or invalid, right? So that's why now we are remaining with 2 possibilities, either we can select 2 or 3. So suppose after thinking we decided to select it, let's say with 2. So if you select the 2, then what will happen? So here I selected 2, right? And I will then move to the next index, and since here I selected 2, which is actually not the actual digit present in the string, then it means that if I select here and fill it with 2, then for the remaining part the value of type will get false. That is, I can fill each and every block from 0 to 9 whatever we want, right? Because the value of type will get 0, because if I am selecting here 2, which is not the upper bound, then we know that this thing happens. So, and even if you select 3, then the same thing will happen, because 3 is also not the upper bound value. So again the value of type will be false for the remaining block, right? So suppose I selected 2 here and moved to the next block, and when I have moved to the next block, then I know that we had the possibilities of selecting anything from 0 till 9, right? So the possibilities that are there for this first index is nothing but from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? And we know that this is just a one single case. We cannot divide it into 2 cases unlike before, right? Because there is no upper bound value present in this anymore. But again, you know very well that though we are allowed to select any value in this range now, but if we try to select any value apart from these 4, then again the whole integer will comprise of at least one digit which is not present in this digits array, and then the whole integer will again get invalid. So that's why we can only select from these 4 choices, that is 3, 2, 8 or 9. So if I mark it here, then again the choices that we are left with is nothing but this 3, 2, 8 and 9. So we cannot select any other integer. Got it? So suppose I decided to select let's say 8 this time. So what will happen if I select 8? So if I select 8 here, then after selecting 8, I will write 8 here, and previously 2 was present, and then I will move to the next block. And since we know that the condition of type is already broken, that is the condition of type will again be false for this block and this block. So again for this block I have choices to fill it with each and every integer from 0 till 9, right? So if I write here, then these are the 10 choices we have, and this is just a one single case, right? And in this the allowed values are nothing but 3, 2, 8 and 9, right? That is 3, 2, 8 and 9. So now we know very well that what we can do is we can just pick one integer. So suppose here I decided to pick, let's say 9, right? So if I pick 9 here, then what will happen? So I will just pick a 9. So till now the condition will be something like 2, then 3, then 9, and then I will move to the next block, right? And again the condition of type will be false for this, and since the value of type will be false, so it means that we can again fill it with any value from 0 till 9, right? That is this. And in this the possible digits that we can select is 3, 2, 8 and 9. And suppose out of these 4 possible digits we are selecting 3 this time. So if we select 3, then till now the condition will be something like 2, 3, 9 and 3, right? So whatever integer has been formed till now is valid. And now again we will move to the next block. So again for the next block we can write anything from 0 to 9 because the condition of type is false, right? And this will just be a one single case, and the values that we are allowed to select is nothing but this 3, 2, 8, 9, and out of these 4 we can select any, right? So suppose we decided to select this let's say 2. So if I select here 2, then what will happen? So if I select 2 here, so I selected 2. So this is very important, now see carefully. So if I select 2 here, then clearly the formed integer till now is nothing but this 2, 8, 9. So let me write here, the formed integer is nothing but this 2, then we selected 8, then we selected 9, then we selected 3, and then we again selected 2. So this is the ultimate formed integer. And how we will know that the integer has been successfully formed? Because after completing this iteration we will move to the 5th index, which will be actually equal to the size of the integer. So in this way we will conclude that our integer has been formed. And now if you see, then each and every digit present in this formed integer is actually present in this digits array that I have considered here, right? So that's why this is a valid integer and it will definitely contribute +1 to our answer. And in this way only we will try out each and every other possibility, because if you do it in this way, then recursively it will just try out each and every possibility, because initially we had the possibility of 2 and 3, then for the next we had the possibility of 2, 3, 8, 9, and again 2, 3, 8, 9, and again 2, 3, 8, 9, and again 2, 3, 8, 9. So that's why by doing it like this, all the possibilities, that is all the possible integers, will be checked automatically. So I think this is the most important concept here till now. So let us now try to understand what states will be required in order to write this recursion. So as you might have guessed, that the first state that will be required here is nothing but the idx, because each time we are moving forward and the index is changing, right? So that's why this index will be our very first state. The second state here will be nothing but this type, because it is helping us to determine at what digits we can fill it, that is a particular block. So this will be our second state, right? So this will be a boolean type and this will be a integer type, right? And let's now try to think what other state is required here. So what will be our third state? So since in the question we want to try out each and every possibility in this range, that is from 1 to n. So how this 1 will be checked and how this 2 will be checked? Because we want to test out each and every integer present between 1 to n. So in order to check 1, the formed digit will look something like this, that is 0, 0, 0, 0 and then 1. Similarly, if we want to try out anything between 1 to n, that is from 1 till this n, let's say here something like 300, then again the formed integer will look something like this, right? So in order to test 300, you can never ignore these leading zeros. This is what I am trying to say here. So only if you write these 2 zeros here, then only this 300 will be written here. And in this way, the value of whole integer will represent nothing but this 300. And that's why you cannot ignore leading zeros here in this question. Because if you ignore leading zeros, then what it will do is, it will never place 0 initially. Right, and if it never places 0 initially, then it will miss out many of the integers less than n, right? So that's why this leading 0 will be our third state, which will help us to explore each and every integer less than n. And if you do not use this leading 0, then it will only start from this first block using either 2 or 3, that is either 2 or 3. And that's why many such integers that can have been less than n and have been valid will be definitely missed. So I hope you got this point. So that's why this leading zeros will be our third state here, right? So that's why if you're solving any problem, then if you have an option of selecting leading zeros as a state or not, then you should definitely select, because by using this leading 0 as one of the state, what it does is it checks out each and every possible integer in that range successfully and does not ignore any integer. And since we want to check out each and every integer, that's why this leading zeros will be important here, right? So now once you have understood all of these things, the last thing that you should know is how we will actually check at each one of the index that if it is possible to use a particular digit or not, because we know that when we were standing at the second index, then we had the possibility of selecting from 0 to 9, but out of all these 10 possibilities, the actual possibilities were these 4 only. So how we will know at a particular index if a particular current digit can be used or not? That is, we should have the idea of that this 3 can be used, this 2 can be used, this 8 can be used, and this 9 can be used, and only these 4 can be used. So how we will know this? So again, if you have watched my third video, then in that video I have explained you the concept of bit masking. That is how we can use a mask in order to keep a information. So in this question also we will do the same thing only. That is, I will just use a mask here. So if I write it here, then it will be something like, I have defined a mask here. So this mask will be nothing but an integer variable only, that is a total of 32 bits. That is starting from 0th bit and going till the 31st bit, right? And we know that since we only need to deal with the digits from 0 to 9, that is initially we know that all the digits will be turned off, that is unset, right? So each and every digit will be unset because the value of this mask variable will be nothing but 0, right? And since we know that for this particular example, the only digits that we are allowed to use is 3, 2, 8 and 9. So what we will do is, for this third bit and the second bit and the 8th bit and the 9th bit, we will simply turn it on. So if we turn it on, then it will look something like this now, right? So that's why this mask will be very helpful now, because whenever now we'll be present at a particular index and want to decide if we can use a particular digit or not, then we will simply see its value in this mask variable, right? So if in this mask variable for that current digit the bit is turned on, so if it is turned on, then it means that we can use it, right? There is no problem. But if it is turned off, then it means that we cannot use it. Why? Because actually that digit was not present in this digits array, and that's why it remained turned off in this mask also. So that's why this mask will be very helpful in this problem as well, right? So this is the whole logic I think required to solve this problem, and I told you each and everything in very detail, how we will form the integer and what states will be required and why we cannot ignore leading zeros in this problem, because if we ignore the leading zeros then we will miss out so many integers which we do not want, and also how we will know that if we can use a particular digit at a current position or not. So that's why we will use a mask here, and also that's why this mask will remain constant, right? So it will not change. So once we have updated the bits position initially using this digits array, this mask will remain constant. So that's why this mask is not one of my states in this problem. So now I think I have explained you each and everything in very detail, and now it will be very good if you actually move to the coding part and code this up quickly, right? So let us go to the code editor now. As I told you that first we will declare a mask here. So the mask will use a value of 0 initially, and I will simply iterate through this digits array, and we know that each of the element of digits array is nothing but a string here, right? So that's why what I will do is I will first convert this given string into an integer, right? So a given string into an integer, that is this, and after converting it into an integer, I simply have to set its value in this mask array, integer, right? So by doing this thing, that is this, we will be actually setting each and every digit in this mask variable to 1, right? And once this is done, we know what we have to do. We have to convert the given n into a string, right? So that is this. And after converting it to the string, let's call the function here. Let's call it f, and we'll initially pass this string s, right? And let us start writing the function here now. So the name of the function is f, and it will return an integer type, and the first argument here is this string s, right? So the second argument here will be nothing but this index 0, and the value of type will be 1 initially, right? So this will be nothing but this idx, and the second argument will be a boolean type, that is type. So we know that if at any point the value of this index become equals to the string size, then we have to return 1. That is, the string is an integer is successfully formed, that is all the blocks have been filled successfully without any problem. That's why this will be a valid integer. But if it is not the case, then it means that we still have not reached the end yet, that is we are in somewhere between. So here we have to select for the current block that what digits we can fill it with. So lower bound will be 0, and upper bound will be decided by the value of type. So if the value of type is true, then it means that we can go in this range, otherwise it will be 9, right? And that's why you have to iterate each and every possibility here, starting from the lower bound and going all the way till the upper bound, right? So now we know what we used to do. So we should have the track of the leading 0 as well now. So initially the value of leading 0 will be true, right? So this LZ will be true initially, and now we will simply check if this leading 0 was true till now and the current digit that we have selected is 0. So if this is the case, then it means that we want to explore other possibilities, that is integers less than n. So we will simply call out this function again, and this time the s will remain s, index will get increased by 1. So type value will depend like this, that is this. But we know that since we have selected 0 here, that is the given value will definitely be less than n. So that's why for the next block the condition of type will be false. So that's why you can simply write it 0 here, and the leading 0 condition will be true again. But if it is not the case, then it means that the integer that we have selected right now is a non-zero integer. That is, the leading 0 condition will fail. But if it is a non-zero integer, then it might be present or it might not be present in this digits array. So in order to know whether if it is actually present in the digits array or not, we will use the mask here that I have declared. So let me pass the mask here as the last argument. So this is nothing but mask, and we will check if the current digit is actually not present in the mask. So I hope you know how to check this. I already have done this in the previous videos. So if this condition is true, it means that the current digit is actually not set in the mask, that is, it is turned off. And if it is turned off, then it means that we cannot use it. So that's why I will simply continue this iteration. But if it is not the case, then it means that this current digit is actually present in the digits array because it is turned on in the mask. And that's why it means that we can use it definitely, right? So again I will call the same function. The idx value will get increased by 1, and now the type value will depend like this, right? And we know that the leading 0 condition is broken now, so it will be 0, that is false, and this mask will remain as it is because it will not change. And finally we will return this result. So let me declare this result variable here too. So once we have written this, I think I have written the complete logic here. So let us try to run and see if we are correct or not. So I forgot to pass this mask here, so let's do it quickly. And if I again run it, let's see. Okay, and as I told you in the explanation initially that whatever value we'll be calculating for the rightmost part, we have to subtract 1, because for this range actually we are also trying for the 0 integer, and we know that this 0 can never be one of the valid answer, because the only digits that can be present in this digits array will be from 1 to 9. So this 0 will never be present, and if this 0 will never be present, then the 0th integer will never form. So that's why we have to subtract 1 here. And now if I run here, let's see. So as you can see that the test cases are getting passed. So this solution is correct, but let us try to memoize it further. So let us declare the states now. So since we have used a total of 3 states here, so if you have already seen this before, then it means that if its value is not equal to 1, then it means that we have already seen it, right? So we will simply return that, otherwise we will store it here like this. So if I write here, then this is nothing but idx, this is nothing but type, and this is nothing but lz. Same for this, right? And let us also do a meme set here. So let us now try to think what will be the sizes for each of the states. So since these two are nothing but boolean values, so it will be 2. And what will be the size for the index? So if you look in the constraint, then the value of n can go up till 10 to the power 9, right? So if I describe you the same thing here, then the value of n can go up till 10 to the power 9. So it will be something like 1 and remaining 9 zeros, right? So this will be the case, and we know that this particular integer can never form because it is consisting of zeros, and 0 can never be present as one of the digits in the digits array. So if we try to take something 1 less than it, then it will be something like this. So this can be a valid integer because in this 9 is present, and 9 can be present in the digits array, right? If you look in the indexing here, then this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So in order to access this ninth index, you must declare a size of 10 at least, right? So that's why we should keep the size of this as 10, and I think rest is fine. So let us now try to run and see if it is correct or not. So as you can see, it is right till now. Let us submit it. So as you can see that our solution is accepted completely, right? So this is the code that we just wrote, and I have explained you each and everything in very detail. So thank you so much for watching this video till this point. I hope you really understood something new, and it can be helpful in your upcoming interviews or online assessments or any competitive programming contests, right? So if you want me to make these kind of videos regularly, then please consider liking the video and subscribing the channel and sharing it with your friends who need to watch this series, because this series will include each and every question related to DigitDP available on Leetcode, right? Which will be approximately 10 to 12. So yes, if you have not yet subscribed the channel, please consider subscribing it and like this video if you really like this content. And if you have any suggestions for me, you can write in the comment section. I will read your comments and try to act on it. So yeah, thank you so much for watching these videos. Thank you.